In the beginning, the universe had no edges to hold it, no directions to guide it, no lines to separate one thing from another. It was a place without place, a presence without form. And yet, somewhere along the way, this boundless expanse learned to draw borders. Atoms carved out their tiny territories. Stars claimed their luminous domains. Even the cosmos itself revealed an edge, the limit of what we can ever hope to see. How does something born without boundaries learn to create them? For a moment, silence lingers, because this question shouldn't exist. A universe with no edges should not have discovered the idea of inside or outside, of here or there. But it did, and the mystery deepens. If the earliest universe was a seamless ocean of energy, perfectly smooth, perfectly unified, then what cracked that unity? What whispered the first division between one point and the next? We live in a world defined by borders, yet we come from a moment that knew none. So we return to the paradox that frames our journey. If nothing had boundaries, why do we? Before boundaries, there was nowhere for them to exist. No space to stretch across, no time to unfold within, no fabric to tear or stitch or separate. The universe in its earliest moment was not a place, but a condition, a trembling uncertainty at the edge of existence. It was the Planck Era, a time so small and so raw that even calling it a time is misleading, because time itself had not yet learned how to flow. It flickered like a thought struggling to form, like a dream unsure whether to be born or vanish. And in this trembling ambiguity, the cosmos floated as something that was almost nothing, yet far from empty. It was a storm of potential without direction, a sea of possibilities without shape, a whisper of being that did not know what being meant. Physicists call it the quantum foam, a phrase too gentle for what it implies. It was a roiling, chaotic blur of temporary existence, particles appearing and dissolving before they could recognize themselves, space flickering open and shut in violent pulses. Imagine reality trying on 1,000 different identities every instant, only to discard them before they could become real. This was the universe not yet committed to a form, not yet willing to choose a geometry, a dimension, a boundary. Everything was everything, and nothing was anything at all. And in that swirling confusion lay the deepest truth. A boundary cannot exist where no position exists, where here and there have not yet been invented. But the chaos had purpose. Even inside this storm of pure possibility, laws waited like seeds buried in darkness. They were not yet the laws we know. Not gravity, not electromagnetism, not even the basic idea of cause and effect, but the precursors to all order. They existed the way a melody exists before the first note, silent yet inevitable. And the universe, in its wilds vibration, was listening for the moment when these laws would sharpen into meaning. Still, before they did, something stranger happened: the collapse of classical intuition. At scales this small, our logic fails. Questions lose their structure. Concepts like distance, direction, and boundary dissolve into irrelevance. What does it mean for something to be next to something else if the very notion of next has not been invented? Every possible universe that could exist was trying to exist at once. In that instant, if instant can be said, reality was a quantum cloud of competing possibilities. Should it expand? Should it remain still? Should it birth dimensions or collapse into nothing? 1 trillion universes flickered in and out like sparks from an invisible flame. Some lasted a heartbeat, others vanished before even that. Yet among them was one that didn't disappear. Ours. Why? No one knows. But in that choice, that survival of a specific quantum state, the first hint of stability was born. And stability is the first ingredient of a boundary. But stability came slowly, and every step toward order was a rebellion against the chaos that preceded it. The Planck Era was so dense with energy that speaking of location was meaningless. Everything was compressed into a realm smaller than a grain of sand, yet size is a concept that relies on space, and space was still negotiating whether it wanted to exist. So reality behaved like a restless mind trying to imagine itself from nothing. It invented temporary forms, only to erase them. It considered dimensions, only to fold them away. It toyed with symmetries, only to shatter them moments later. And through all this, a philosophical ache emerges. How can you draw a boundary in a universe where nothing yet has identity? How can you define an inside without an outside, or an outside without an inside? Even language collapses under the weight of these questions, because every word we use assumes a world already shaped, a space already structured. There is no vocabulary for a universe before boundaries, only metaphors, only echoes, only intuition guided by equations that strain against their limits. Yet something remarkable was happening. Amid the collapse of certainty, the universe was cooling. Not in the way ice cools or metal cools, but in the way chaos cools, into pattern. As energy density began to ease, even by the smallest margin, the violence of quantum fluctuations softened. Space stopped blinking on and off with such ferocity. Time, once an unstable rhythm, began to choose a direction. And with that direction came the first whisper of flow, the first hint of continuity. Flow is order. Continuity is structure. Structure is the first faint shadow of a boundary. Still, the Planck Era refused to surrender quietly. Every attempt at structure was met with fierce resistance. Space curved violently in ways no modern equation can fully describe. Gravity, if it existed at all, behaved nothing like the gentle curvature we know. Forces tangled and collided. Dimensions twisted, merging and splitting like threads of liquid light. And yet, amid this restless storm, there emerged something essential: differentiation. Tiny asymmetries appeared, cracks in the perfect uniformity of the beginning. These imperfections were subtle, a fluctuation slightly stronger here, slightly weaker there, but they were enough to tilt the future, enough to give the universe one crucial advantage: contrast. And contrast is the birthplace of boundaries. With contrast, the universe could finally begin to distinguish one region from another. To the human mind, this seems trivial, but to a reality that had never known location, it was revolutionary. A boundary does not appear all at once. It begins as an imbalance, a variation, a whisper of difference. And in the quantum foam, difference had finally awakened. Something was shifting. Something was learning to separate. Something was preparing the rules that would allow atoms to form, stars to ignite, galaxies to take shape. But the most profound transformation was philosophical. The universe was learning the concept of identity. Identity emerges only when things are no longer identical. When a symmetry breaks, when a continuity fractures, when a field shifts just enough to create contrast. And in that first break, that cosmic fracture, the earliest proto-boundary was born. Not a wall, not a line, but a tendency toward separation, a preference for structure over chaos, a leaning toward definition. And from that leaning, the universe drew its first breath of order. Yet this transition was not gentle. It came with tension, the kind of tension that splits reality open. Imagine a universe wrestling with itself, grappling between the urge to remain undifferentiated and the urge to become something more. That conflict produced the very fabric of space-time. When the symmetry broke, expansion ignited. Space ballooned outward faster than light, stretching quantum fluctuations into the seeds of galaxies. Suddenly, difference was no longer microscopic. It was cosmic. Tiny wrinkles became vast regions. Quantum noise became the blueprint of everything we see. But even here, boundaries were still infants. Space existed now, yes, but it had not yet settled. It quivered. It stretched unevenly. It expanded with a force so immense that the idea of a stable boundary seemed impossible. Yet that impossibility is what fueled the next transformation. As the universe expanded, energy thinned. As energy thinned, violence eased. As violence eased, laws crystallized. Gravity separated itself from the primordial unity. Forces split like branches breaking from the same trunk. The universe was still wild, but it was becoming knowable. And as the laws settled, regions began to behave differently from one another. Temperature varied, density varied, field strengths varied. These variations sharpened into the earliest structures, and in those structures, faint, fragile, but real, the first stable boundaries began to surface. The difference between here and there, the difference between something and nearly nothing, the difference between the smoothness of the early cosmic sea and the ripples that would one day become galaxies. This is the moment when the universe chose shape over shapelessness. It chose structure over blur. It chose the possibility of worlds over the comfort of chaos. And in that choice, the stage was set for atoms, stars, planets, and life. Boundaries were not accidents. They were the children of instability, born from the fractures of perfection. Yet the greatest mystery remains. Why did the universe choose boundaries at all? Why not remain in the endless freedom of the nowhere era? Why surrender boundless possibility for defined existence? No one knows. Maybe the universe longed to become something specific. Maybe structure was the only way for complexity to awaken. Or maybe boundaries were an inevitable consequence of laws seeking expression. But one thing is certain. Something hidden inside this chaos was preparing the first boundary. It happened in an instant so brief that the word instant feels like an exaggeration. One moment, the universe was a trembling quantum haze, smaller than a proton, younger than a thought. The next, it was racing outward with a violence that rewrote the meaning of speed. This was cosmic inflation. The moment the universe drew its first line, the moment chaos surrendered to something new, separation. What had been compressed into a single nowhere erupted into a vast somewhere. Space inflated so fast that regions once touching, once sharing the same quantum breath, were flung apart beyond the reach of any signal, any influence, any hope of reunion. And in that sudden division, the universe experienced its first boundary, the boundary of causality. Before inflation, everything was intimate. Every fluctuation, every pulse of the quantum foam, every tremor of energy was shared instantly with every other point. The universe was smaller than imagination, and because it was so small, it was unified. Wherever you went, though going meant nothing, you were connected to everything else. But inflation shattered that intimacy. Space didn't simply grow, it tore itself apart. It didn't expand gradually like a balloon. It surged, exploding outward at a rate faster than light could ever dream of. Not because anything moved through space, but because space itself was the thing expanding. Boundaries didn't wait for structure to appear. They were forged in the expansion itself. This expansion created a horizon, not a physical wall, not a surface you could touch, but a limit of influence. A cosmic line beyond which no message could cross, no light could reach, no particle could whisper to another. Suddenly there was beyond. Suddenly there was out of reach. For the first time in its infancy, the universe had a sense of far away. It had a limit, a boundary. And this boundary was no small thing. It shaped everything that came after. Imagine two regions of space that once shared the same quantum fluctuations, the same trembling uncertainty. Inflation hurled them apart with such speed that they were exiled from each other forever. What happened in one could never again affect the other. They became separate worlds, joined only by origin, divided by destiny. This was not an accident. It was the universe choosing which regions would remain connected and which would drift into eternal solitude. Inflation didn't just stretch the canvas, it outlined it. It defined the scale of all future structure. It established the horizon that still surrounds us today, the edge of what we can see, the limit where light has simply not had enough time to reach us. And yet, inflation was not gentle. It was a storm of unimaginable smoothness. As space ballooned, quantum fluctuations were stretched with it, pulled like threads across a growing tapestry. What began as microscopic wrinkles were inflated into cosmic variations. These tiny imbalances, created in the madness of the Planck Era, became the seeds of galaxies. Inflation took the smallest noise in reality and amplified it into the blueprint of everything. The boundary of causality determined which regions would share these patterns and which would evolve alone. Every star, every cluster, every void owes its existence to this moment of violent expansion. But inflation was also strangely calming. As space grew exponentially, its energy density thinned. The chaos of the beginning softened. The universe became smoother, cooler, quieter. Inflation acted as a cosmic iron, flattening wrinkles across the early universe, making the cosmos nearly uniform from one horizon to the next. Yet that smoothness contained within it the faintest imperfections. Imperfections that would one day give rise to structure, life, thought. Still, inflation moved with a pace that defies comprehension. In far less than a microsecond, the universe expanded by a factor many orders of magnitude beyond anything we witness even today. A proton-sized patch of space became the size of a galaxy, and that galaxy-sized patch continued to swell until it formed the observable universe. Inflation didn't just give the cosmos room to grow, it created the very room. It carved out the stage on which reality would unfold. But more important than the room itself was the realization that space could have limits. The cosmic horizon, the boundary of what is observable, is not an edge in the ordinary sense. There is no wall, no barrier, no membrane. There is only distance and time conspiring against our ability to see. Inflation pushed regions so far apart that light from those regions hasn't had enough time to reach us, even after nearly 14 billion years. That horizon is the universe's first true line. It was drawn not with matter, not with energy, but with speed. A speed so extreme that it defined forever what lies within our cosmic bubble and what remains beyond. And here lies the poetic twist. Inflation unified the universe by separating it. Without boundaries, there can be no structure. Without separation, no form. The universe had to divide itself in order to create anything at all. Just as an artist must choose the size of the canvas before painting, the universe chose its scale by throwing itself apart. It chose which regions would share a cosmic fate and which would drift beyond each other's reach. The canvas wasn't blank, it was accelerating. And every scribble of quantum noise became a stroke across the stretching fabric. But inflation did something deeper than carving a horizon. It set the rules for causality. Before inflation, information could roam freely. After inflation, information became local. Every galaxy, every star, every observer would exist inside its own sphere of influence. Beyond that sphere, the universe would remain forever silent. This silence is not empty. It is filled with worlds we will never know, structures we will never touch, galaxies born from fluctuations that inflated far beyond our horizon. The first boundary wasn't a physical structure. It was a rule. The rule that not everything can touch everything else. And this rule transforms reality as profoundly as the creation of space itself. Without causality boundaries, structure cannot emerge. When information can flow everywhere immediately, the universe cannot develop complexity. Everything influences everything else too quickly, too strongly. But once regions become isolated, once they begin to evolve independently, structure blossoms. Inflation gave birth to independence, and independence gave birth to identity. Still, questions linger like shadows at the edge of comprehension. Why did inflation happen? What field triggered this explosive growth? What caused it to stop? No one truly knows, but whatever sparked it, inflation was the event that set the cosmic stage. It fixed the scale of the universe. It locked in the patterns of primordial fluctuations. It forged the horizon that defines our observable world. And it marked the moment when reality stepped out of the blur of nothingness and began choosing form over chaos. As inflation roared to a stop, space stabilized. The universe transitioned into a calmer expansion, one that continues today, but at a far more sedate pace. The cosmic horizon remained, a quiet line wrapped around us, reminding us of the violence that created it. Everything inside that line shares a common past, a past born from the same proton-sized seed. Everything beyond it might as well be another universe, cut off not by walls, but by time itself. And so, from the smallest spark of existence, inflation sculpted the largest boundary imaginable. It shaped not just space, but destiny. It determined which galaxies would ever see each other, which atoms would ever meet, which regions would forever drift in isolation. Inflation didn't merely give the universe scale. It gave it structure by preventing connection. It taught the cosmos that limits are not flaws. They are invitations for complexity. Yet the story doesn't end with the boundary we see. Inflation may have created countless horizons, beyond ours, beyond our comprehension, each bubble of space-time expanding like islands in an endless ocean. If inflation happened once, perhaps it happens eternally. Perhaps boundaries are not the edges of the universe, but the signatures of endless creation. But that is a question for later. For now, we sit inside our cosmic bubble, knowing that the first true division of reality was drawn long before stars were born. Because inflation didn't just stretch space, it carved the boundaries of reality itself. In the beginning, the universe was perfect. Too perfect. A flawless symmetry held everything together, every force unified, every particle indistinguishable from the next. It was a state so smooth, so exquisitely balanced, that nothing within it could take shape. Because absolute symmetry is absolute sameness, and in absolute sameness, nothing can stand apart long enough to become real. Boundaries could not emerge, because difference could not exist. The universe was still a single idea, unbroken, unexpressed, whole. But perfection, in this cosmic sense, was unstable. It carried within it the tension of possibility, and as the universe cooled, that tension fractured, symmetry broke, and in that breaking, the universe learned to draw its first laws. The first great fracture came swiftly. Gravity, once fused with the other forces in a single primordial unity, split away. Its separation was subtle at first, like a quiet shift beneath an ocean of energy, but its consequences were profound. By detaching from the unified field, gravity became the first force to gain identity. It shaped the fabric of space-time, teaching reality that curvature could replace chaos, that mass could influence geometry, that attraction could bind. This was not just a new force, it was the universe's first decision. A boundary formed, not a physical edge but a conceptual one, dividing what gravity governed from what it did not. In that distinction lay the first whisper of structure. As the universe continued to expand and cool, the next fracture followed. The strong nuclear force separated, ripping itself free with unimaginable intensity. Before this moment, forces behaved as one, indistinguishable, unified. Afterward, the strong force became the cosmic glue responsible for binding quarks into protons and neutrons. Suddenly, relationships changed. Interactions that once occurred uniformly across reality were now governed by new rules. The universe had introduced a distinction between what could be bound and what could not. A new layer of identity, a new kind of boundary. These boundaries weren't like walls or lines. They were deeper, woven into the operating system of physics itself. Before symmetry breaking, particles had no individual character. After symmetry breaking, each force imposed its own domain. Gravity sculpted space-time on cosmic scales. The strong force sculpted matter on subatomic scales. Regions of influence diverged, and the universe began to differentiate itself with extraordinary precision. What had been a timeless ocean of sameness became a world of roles, interactions, and constraints. And in these constraints, order emerged. But the universe was not done fragmenting. As temperatures dropped further, another symmetry shattered, one far more delicate. The electroweak force, a unified field of both electricity and radioactivity, began to split. At higher energies, they were indistinguishable. At lower energies, the weak nuclear force broke away, leaving electromagnetism to govern light and charge. This moment is one of the most mysterious transformations in physics, because it is the moment when particles gained mass. Before symmetry breaking, mass didn't exist. Everything moved at light speed. Everything was ethereal, weightless, undefined. With the electroweak symmetry broken, the Higgs field permeated space, slowing some particles, granting them inertia, giving them identity through resistance. A boundary appeared between the massive and the massless, between light that could glide freely and particles that were forever anchored by their interaction with the Higgs field. This boundary gave rise to the very concept of substance. Without it, atoms would never form, stars would never ignite, planets would never exist, and consciousness would never wonder why. Consider the philosophical weight of this moment. A universe that began in total equality, no forces separate, no particles distinct, now found itself full of differences. The universe was learning to classify itself, to create categories, to define relationships. Where once everything behaved the same, now each interaction carried its own purpose. And this diversity was not a flaw. It was the essential ingredient of complexity. Without symmetry breaking, reality would remain a smooth, undifferentiated field incapable of form. By shattering its initial perfection, the universe created the possibility of structure. We tend to imagine boundaries as rigid edges, but here, boundaries were transformations. Transitions where laws changed, where particles took on new identities, where interactions gained new meaning. These boundaries were written into nature at the most fundamental level. They defined what forces could act on what particles could interact, and how energy could transform. Each broken symmetry added a new layer to the cosmic hierarchy, a new rule in the universe's growing playbook. The unified whole was giving birth to a structured many. The deeper we look, the more extraordinary this process becomes. Symmetry breaking didn't just create differences, it created relationships. It introduced the idea that certain particles belonged together and others did not, that certain interactions were possible and others forbidden, that certain transformations could occur and others were forever sealed off. These constraints guided the evolution of matter, directing energy toward the construction of atoms, molecules, stars, and galaxies. Without these invisible boundaries, the universe would collapse back into sameness, stripped of the complexity that defines everything we know. There is a philosophical ache in this realization. The universe chose imperfection in order to exist. It abandoned perfect unity so that structure could form. It allowed itself to fracture so that meaning could emerge. In that sense, symmetry breaking is not simply a physical process. It is the universe's first creative act, the moment it began differentiating itself into something capable of stories, of life, of observers who could look back and ask why. Consider how this fragmentation shaped everything that followed. Once gravity stood apart, it determined how matter would cluster. Once the strong force emerged, it dictated how matter would bind. Once electromagnetism separated, it controlled how atoms would form, how chemistry would unfold, how light would travel. Each broken symmetry set a new boundary, a limit on what could happen, and a pathway for how it should happen. These were not arbitrary, they were the foundation stones of reality. But the story is still deeper. Symmetry breaking also introduced asymmetry. Tiny imbalances in the early universe that favored matter slightly more than antimatter. Without this imbalance, matter and antimatter would have annihilated perfectly, leaving behind a universe filled with only radiation. Instead, because symmetry broke in just the right way, matter survived. Every star, every planet, every cell in your body exists because symmetry breaking refused to allow perfect cancellation. Imperfection was salvation. As the cosmic temperature continued to fall, particles differentiated further. Quarks arranged themselves into protons and neutrons. Neutrinos slipped almost silently through space, untethered by the strong or electromagnetic forces. Photons streamed freely, carrying the first whispers of light across expanding space. Each category, each role, each behavior emerged because symmetry had shattered. The universe was composing itself like a symphony, each instrument born from a broken note in the original chord. And yet, for all this growing order, a tension lingered. A quiet reminder of the perfection that once was. Physicists still search for a deeper symmetry connecting all forces, a grand unification hidden beneath the surface of broken laws. They suspect that the boundaries between forces are not fundamental, but scars left by cosmic transitions we can barely imagine. In this view, the universe still carries within it the memory of its original unity, encoded in equations we have not yet solved. But memory is not destiny. The universe we see today is one defined by difference. Difference gives rise to hierarchy. Hierarchy gives rise to complexity. Complexity gives rise to structure. And structure gives rise to meaning. If symmetry had never broken, none of this would exist. There would be no atoms, no stars, no galaxies, no life, no questioners. Boundaries were not imposed on the universe. They were chosen by the universe. They are the marks of its evolution, the fingerprints of its desire to become more than a silent, perfect whole. And so the universe, once unified beyond comprehension, became a layered reality. Forces divided, particles categorized, interactions ruled by distinctions that grew sharper with time. This fragmentation was not destruction, it was creation, the birth of diversity, the birth of identity, the birth of the rules that govern everything from the orbit of galaxies to the firing of neurons. Every boundary you know, every limit, every difference, every distinction between one thing and another can trace its ancestry back to the breaking of primordial symmetry. Because in the moment the universe shattered its perfection, it wrote the first chapter of structure. It learned to define. It learned to separate. It learned to create. And from these fractal divisions, from these invisible boundaries etched into the laws of physics, the cosmos gained shape, depth, and possibility. From the shattering of symmetry came the blueprint for every boundary you know. For hundreds of thousands of years after the birth of the universe, everything remained too hot, too wild, too frantic for structure to hold. Electrons skittered through the cosmic firestorm like sparks that refused to land. Protons and neutrons drifted alone, unable to gather companions. It was a universe of pieces with no way to fit together, an ocean of charged particles that could not settle, could not bind, could not slow long enough to become anything more than chaos. But chaos was cooling. Expansion was stretching the fabric of reality, thinning the cosmic plasma until its heat slowly surrendered. And in that surrender, a threshold approached. A moment when particles that had once flown freely would finally move slowly enough to feel the delicate pull of a new boundary. The electromagnetic force was preparing to perform its first miracle. Recombination began not as a single instant, but as a quiet shift. Temperatures dropped below 3,000 degrees, and suddenly electrons that once danced at impossible speeds found themselves captured by the waiting protons. It was as if the universe, after rushing forward in fiery expansion, paused long enough to breathe in, and in that breath, the first atoms formed. Not stars, not galaxies, not worlds, atoms. The smallest containers of structure the universe had ever known. Their creation was nothing short of revolutionary. For the first time, the cosmos learned how to hold itself together. An atom is a boundary disguised as simplicity. At its heart lies a proton, a tiny fortress of quarks held tight by the strong nuclear force. But that fortress alone is not an atom. The boundary emerges only when an electron enters the picture. That lone electron, captured by electromagnetism, doesn't crash into the proton. Instead, it occupies a shell, a region of space defined not by solid walls, but by the laws of quantum mechanics. This shell is the atom's essence. It defines where the electron is permitted to exist, and just as importantly, where it is not. The universe had created a new kind of inside. Before atoms, there was no meaningful distinction between one region of plasma and another. Particles roared freely, colliding, scattering, losing themselves in an endless sea of motion. But when electrons bonded to nuclei, something astonishing happened. Location gained significance. A boundary formed around each atom, not as a physical surface, but as a probability cloud, a region beyond which the electron would not stray without effort, without energy, without a reason. For the first time, the cosmos had individual units, accountable many, a way to say this and that. Inside each atom exists a miniature landscape, an interior defined by forces rather than walls. The nucleus anchors the structure, its positive charge creating the attractive pull that shapes the electron's orbit. The electron, governed by quantum rules, is never still. It does not circle like a planet, nor hover like a dust mote. It exists as a wave of possibility spread across a defined region, contained by the very force that binds it. Here, boundaries arise from balance. Too much energy, and the electron escapes. Too little, and the atom collapses. But in the perfect middle lies stability. In that stability lies identity. Consider what this means philosophically. In a universe that began without edges, without forms, without separation, atoms represent the first intentional divisions of matter. They are the earliest expressions of individuality. Each atom is unique not because of its composition. Hydrogen atoms are nearly identical, but because of its discrete existence. One atom cannot simply flow into another. Their boundaries repel collapse. They maintain personal space through the elegance of force. This is the universe learning to contain itself, one electron shell at a time. Electromagnetism is the sculptor here. Unlike gravity, which gathers mass into great swirls of cosmic structure, electromagnetism establishes fine lines, tight boundaries between particles. It prevents matter from dissolving into undifferentiated fields, pushing electrons into distinct energy levels and keeping atoms from overlapping. Without this force, every proton and electron would simply merge into a smeared continuum. No chemistry, no structure, no possibility of life. The everyday solidity of matter, the reason your hand does not pass through a table, is simply the cumulative effect of electromagnetic boundaries. Reality feels solid because atoms refuse to share their shells. Zoom out from the subatomic scale, and the transformation becomes even more astonishing. As billions upon billions of atoms form across the universe, the cosmic fog begins to clear. Photons, once trapped in the dense plasma, are suddenly free to travel. This moment, the decoupling of light, becomes the cosmic microwave background, the oldest light we can see, whispering the story of the universe's first boundaries. What was once opaque becomes transparent. What was once chaos becomes clarity. Atoms made this possible. Their formation reduced scattering, allowing light to flow unobstructed. Each atom that formed was a declaration. Here is a boundary. Hydrogen, helium, and traces of lithium filled the cosmos like seeds scattered across a dark field. These atoms drifted, cooled, and gathered. Their boundaries allowed gravitational attraction to take hold, building clouds, then stars, then galaxies. Without electromagnetic containment, gravity would have nothing stable to work with. The first atoms were not merely particles. They were the starting points of structure, the punctuation marks in the universe's expanding sentence. Yet the intimacy of atoms hides a deeper truth. Their boundaries are not hard. They are soft, probabilistic, shimmering with uncertainty. The electron shell is not a barrier you can touch, but a region defined by rules, a compromise between attraction and motion. In that compromise lies beauty. Atoms exist as balanced negotiations between forces, and from these negotiations emerge the building blocks of everything. But let us look closer. Each atom's boundary is different depending on its charge, its energy, its interactions. When atoms meet, their boundaries dance, interacting through attraction or repulsion. This dance creates molecules, another kind of structure, another layer of boundary making. But that comes later. First came the moment the universe realized an atom could hold, that it could last, that it could serve as a unit of structure rather than a fleeting fluctuation. Atoms introduced permanence into a universe that had known only flux. They introduced stability into a cosmos that had been expanding, cooling, transforming, but not yet forming objects with longevity. For the first time, matter could persist. Hydrogen atoms formed and remained intact for billions of years. Their boundaries did not erode with time. They survived stars, explosions, and cosmic collisions. They carried the memory of the early universe into every corner of space, and they made separation meaningful. Before atoms, separating 2 points in plasma meant little. Everything influenced everything else in a thick soup of interactions. But atoms do not blur. They are discrete. One atom is not half of another. Their boundaries ensure distinction. This is the universe's first true articulation of individuality. Particles held together not just by forces, but by rules that dictate where each component must remain. From a philosophical view, this is extraordinary. The universe that once rejected boundaries is now full of them. Each atom is a lesson in containment, in structure, in the transformation of chaos into form. Each shell is a quiet declaration that reality is not arbitrary, that it chooses to bind, to shape, to define. And in these choices, new possibilities unfold. Zooming outward again, the cosmos begins to fill with these tiny universes of structure. Clouds as hydrogen gather under gravity's pull, their atomic boundaries allowing them to compress, collapse, and ignite into the first stars. Those stars fuse atoms into heavier elements, adding new boundaries, new complexity. Oxygen, carbon, nitrogen, each born from stellar fire, carries more intricate shells, more sophisticated rules, more potential for structure. Life eventually emerges from these complex atoms, each boundary a step toward consciousness. But in this act, we stay with the first moment, the birth of atoms as boundary makers. The moment when electrons slowed enough to be captured, when protons gained companions, when shells formed. When the universe discovered the idea of an inside. Every boundary since then echoes this first containment, this first agreement between force and particle. Atoms were not the end of structure. They were the beginning, the smallest expressions of a cosmic desire for form. They taught the universe how to differentiate, how to organize, how to build upward from simplicity into complexity. They were the first answers to the question, how does the universe decide what stays together and what stays apart? This question is still unfolding, still echoed in the structure of galaxies, the arrangement of molecules, the architecture of living cells, but its origin is here. In recombination, when electrons learn to stay, when forces learn to hold, when matter learned to define itself. And as the universe continued to evolve, new structures were waiting. New boundaries were rising. Atoms were only the first whisper of a deeper architecture, one that would soon reshape the cosmos on every scale. But atoms were only the beginning. Greater boundaries were coming. When the first atoms drifted across the newborn universe, they floated in near-perfect silence. No stars burned, no galaxies spiraled, no clusters gathered in the dark. The cosmos was smooth, almost too smooth, a vast expanse of hydrogen and helium, spread thinly and evenly across widening space, but not perfectly. In the faint static of the cosmic microwave background, tiny variations hid like whispers in a cathedral, regions slightly denser, slightly warmer, slightly more inclined to gather. These imperfections were relics of fluctuations stretched during inflation, and they were the first signs that gravity would soon take the stage. For gravity is a boundary maker on a grander scale, shaping matter not through containment like electromagnetism, but through attraction, through the quiet persuasion of curvature. And in these tiny differences, gravity found the seeds of structure. Slowly, impossibly slowly, atoms drifted toward the denser regions. What began as slight variations grew into gravitational wells. Clouds formed, expanding invisibly across light years. Gravity was patient. It tugged, coaxed, gathered, transforming smoothness into clumps, clumps into clouds, and clouds into the first grand boundaries of scale. Every galaxy we know began as a faint ripple in the early universe, a subtle bump in density that gravity amplified across millions of years. From these ripples emerged the scaffolding of the cosmic web, filaments stretching across hundreds of millions of light years, voids where matter fled, clusters where galaxies huddled in luminous families. The universe was no longer an undifferentiated sea. It had learned to draw lines across its own immensity. But within these gravitational nurseries, something more dramatic was unfolding. As clouds of hydrogen collapsed inward, their boundaries sharpened. Matter spiraled, heating under the pressure of its own weight, and in the heart of each collapsing cloud a confrontation began. Gravity pulled relentlessly inward, demanding collapse. But collapse alone does not make a star. At a critical threshold, when pressure and temperature rose high enough, another force awakened. Radiation. Light pushed outward against gravity's inward hunger. And in this clash, a star found its shape. A star is a boundary sculpted not by walls or shells, but by tension. In its core, nuclear fusion ignites, releasing photons that struggle to escape the dense plasma. Those photons push outward with astonishing pressure, resisting gravity's desire to compress the star into a smaller, denser form. Gravity pulls, radiation pushes. Between them is the equilibrium where a star survives. This boundary is delicate, dynamic, constantly shifting as fuel burns and light fights back. Yet it is extraordinarily stable. Some stars maintain this balance for billions of years, their boundaries glowing across cosmic distance as symbols of harmony born from violence. Consider the surface of a star. Not a solid surface, but a transition zone. Inside lies a roaring inferno, a convective ocean of plasma. Outside lies the vacuum of space, cold and vast. The star's surface is simply where light finally escapes, after countless collisions and absorptions. It is a boundary witnessed as brilliance, a border defined by escape velocity, opacity, temperature, and radiant force. Without this boundary, light would never leave the star, and the universe would remain dark, blind to its own creations. But stars were not content merely to shine. Within them, new boundaries formed at even smaller scales. Fusion crafted heavier elements: carbon, oxygen, nitrogen, silicon, iron. The elements that would one day become worlds, oceans, air, and bodies. In a star's core, atoms are pressed so tightly together that new nuclei merge, forming new boundaries inside new structures. The architecture of edges expands inward and outward simultaneously. A star is not just a glowing sphere. It is a factory of distinctions. Zoom outward again and the universe reveals its scaffolding in greater glory. Galaxies swirl as cosmic cities. Their arms spin with stars whose boundaries hold steady in unison. Dark matter halos surround them, unseen but essential, providing gravitational anchors that keep galaxies from flying apart. Even dark matter creates boundaries, invisible ones, shaping where galaxies form and where they cannot. And between the galaxies lie vast voids, where gravity has carved emptiness, the negative spaces that give structure meaning. Look at any galaxy cluster. Here, hundreds or thousands of galaxies orbit a shared gravitational heart. Their interactions create shock waves of gas, boundaries upon boundaries layered across scales beyond comprehension. Each galaxy carries inside it billions of stars. Each star carries inside it trillions of atoms, and each atom holds its electron shell, an echo of the earliest boundary. The architecture of edges repeats, fractal-like, from the subatomic to the cosmic. A star's boundary mirrors an atom's boundary, containment by force, equilibrium through contrast. The universe is consistent in its creativity. Philosophically, this era marks a profound shift. The universe is no longer merely cooling, expanding, or differentiating. It is becoming expressive. It is building forms that endure. Stars introduce longevity into the cosmic narrative. Their boundaries allow them to persist, to radiate, to sculpt their surroundings. A star lives because the forces within it negotiate a truce. Identity emerges from this negotiation. Without boundaries, a cloud would collapse forever, extinguishing itself in gravitational implosion. Without boundaries, radiation would scatter too quickly to ignite fusion. Boundaries are the conditions that let a star exist as something distinct, something stable, something radiant. And stars, in turn, shape galaxies. Their winds carve bubbles in interstellar gas. Their supernovae blast heavy elements across light years, creating shock fronts where new stars form. Boundaries ripple outward endlessly. Each star's death redraws the edges of the galaxy that created it. In this sense, cosmic boundaries are alive, constantly shifting, expanding, and dissolving, yet leaving behind imprints that guide new structure. There is a quiet beauty in this process. Gravity gathers matter into luminous enclaves. Radiation pushes back to keep them from collapsing. These tensions birth forms that carry meaning, from the first star igniting in the dark to the billions that trace the galaxies we see today. The night sky is not a scattering of random points. It is the visible expression of boundaries, regions where forces chose balance over collapse, structure over chaos, and without stars, nothing meaningful could have emerged. They forged the elements needed for planets, oceans, chemistry, and eventually consciousness. They sculpted the cosmic web into patterns our minds instinctively recognize. Spirals, clusters, filaments, voids. Our sense of pattern, of beauty, of structure comes from a universe that learned to create edges. Boundaries do not constrain meaning, they enable it. Through separation, identity arises. Through identity, complexity blossoms. Through complexity, awareness awakens. Consider how extraordinary this is. The universe began with no distinctions, no edges, no forms. And yet here, in the architecture of galaxies and stars, we witness an explosion of variation. Every galaxy cluster, every nebula, every star is a declaration of difference, a testament to the power of boundaries to generate individuality. What began as fluctuations in a microwave background became the scaffolding of reality. Gravity transformed faint patterns into cosmic skeletons, and stars filled those skeletons with light. And so we return to the essential truth. Stars are boundaries made luminous. Their surfaces, though not solid, mark the transition between energy trapped and energy freed. Their cores mark the transition between atoms fused and atoms waiting. Their gravity marks the difference between collapse and equilibrium. Their lives mark the difference between chaos and creation. Each star is a boundary that breathes, burns, and eventually breaks to seed the universe with new possibilities. As galaxies continued to evolve, these boundaries multiplied. Supermassive black holes formed in galactic centers, introducing event horizons, boundaries of such extreme gravity that not even light can escape. Shock waves from star formation carved cavities in interstellar gas. Magnetic fields traced invisible edges across plasma. Everywhere boundaries shaped the evolution of structure. They determined where new stars formed, how galaxies spun, where clusters gathered. The cosmic architecture became a tapestry of edges interacting across unimaginable distances. Without these edges, you would not exist. It is only because stars forged elements in their cores, only because supernovae scattered them across space, only because gravity gathered them into planets, only because boundaries allowed chemistry to flourish, that life emerged to reflect on the boundaries of the universe itself. Each breath you take is made from atoms once shaped in a star's furnace. The calcium in your bones, the oxygen in your lungs, the iron in your blood, all were born from boundaries that stars negotiated into existence. And so we arrive at a cosmic revelation. As stars forged boundaries, they also forged the ingredients of the beings who would one day question them. The universe we see is not the universe that exists. This is the first truth we must face when we speak of the cosmic horizon. The greatest boundary ever drawn, not by walls or matter or force, but by time itself. We live inside a bubble of visibility, a sphere carved out by the finite speed of light and the relentless expansion of space. Everything we know, everything we have ever measured, imagined, or proven is contained within this fragile sphere. Beyond it stretches a cosmos so vast, so unreachable, that no thought or photon will ever cross the gulf between us, and yet it is there. It influences us. It shapes the background of our sky. But it will remain forever hidden. To understand the cosmic horizon, we must begin with something deceptively simple. Light is fast, but not infinite. It takes time for light to travel, and the universe has not given it infinite time. When we look at a star 10 light years away, we see it as it was 10 years ago. When we look at galaxies millions of light years away, we see them as they were millions of years ago. And when we look at the cosmic microwave background, we see the faint glow of the universe when it was only 380,000 years old. Every direction we gaze, we are peering back into deeper layers of time, peeling reality like an onion, until time itself becomes too young to show us anything more. That is the first boundary, a temporal edge, but it is not the last. Space itself is expanding, driven outward by dark energy, an invisible pressure that accelerates the stretching of the cosmos. This expansion does something extraordinary. It not only separates distant galaxies from us, it accelerates them away faster than light. This does not violate physics, because nothing is moving through space faster than light. Rather, space itself is expanding between us and those distant realms. At great enough distances, galaxies recede so quickly that their light can never catch up. They fade from possibility. They slip permanently beyond our horizon. It is not a matter of waiting long enough. No amount of time will ever let their light reach us. A boundary forms, absolute, unbreakable, irreversible. This cosmic horizon surrounds us like a sphere of ignorance, about 46 billion light years in radius, even though the universe itself is likely far larger, perhaps infinite. Everything beyond that radius exists, but not for us. Our instruments cannot detect it. Our telescopes cannot glimpse it. Our equations can infer it, but not confirm it. We are cut off from the vast majority of the universe by the simple fact that time has limits, and expansion has no mercy. The horizon is the line where visibility ends and speculation begins. Imagine standing on a shore, staring across an ocean. You see waves, clouds, shifting patterns of light. You know there is more beyond the horizon, but you cannot see it no matter how hard you try. Now stretch that ocean into a cosmic scale, galaxies, clusters, superclusters, voids, filaments, and realize that what lies beyond your horizon is not simply distant land, but the majority of the universe. Structures larger than imagination expand in directions we will never witness. Light from foreign stars will never reach your eyes. You are surrounded by an ocean without end, but your view is bounded by an unwavering, invisible line. Philosophically, this raises unsettling questions. Are we imprisoned within a region of the cosmos? Is our understanding forever incomplete, not because of ignorance, but because of the laws of physics themselves? We often imagine scientific progress as a march toward complete knowledge, a gradual illumination of mysteries. But the cosmic horizon reminds us that some mysteries are not merely difficult, they are inaccessible. There is no future telescope, no technological miracle, no theoretical breakthrough that will let us see beyond this boundary. It is the ultimate edge, the limit of knowability, and yet this boundary does not separate nothing from something. Beyond the horizon lies more universe, teeming, evolving, expanding. Galaxies we will never observe continue their lives, birthing stars, collapsing into black holes, scattering radiation across space. Their gravity still pulls on the cosmic web, subtly shaping the distribution of matter within our horizon. They act upon us without revealing themselves. They are the unseen architects of patterns we can measure but never fully explain. That is the paradox. The horizon hides the universe from us, but the hidden universe continues to shape the one we can see. This realization forces us into a deeper, more vulnerable reflection. Our cosmic neighborhood, the galaxies within billions of light years, feels immense, yet it is a fraction of what exists. Most of the universe is permanently outside our reach. The cosmic horizon is not a border we will someday cross. It is an edge that moves away faster than we can chase it, a boundary expanding at the speed of creation itself. As time passes, more galaxies fade beyond it. The observable universe grows in size, but not in content. What we can see is destined to shrink in richness, even as space grows in volume. The Earth's horizon is both cradle and coffin. It shelters us in knowability, but seals us away from the infinite. Look again at the night sky. The stars you see belong to a mere pinprick of cosmic territory. The Milky Way is a single thread in a vast tapestry. The local group of galaxies is a tiny island. Beyond it stretches the Virgo supercluster, the Laniakea supercluster, and beyond that, filaments of matter forming a cosmic web spanning billions of light years. But beyond even this web, beyond its farthest filaments, lies the unreachable. Light from those regions will never arrive. They are part of our universe, but not part of our observable universe. The horizon draws its quiet circle around all we will ever know. There is a strange comfort in this limitation. Boundaries define identity, and the cosmic horizon defines ours. We are the observers inside this bubble of visibility, interpreters of the portion of reality allowed to touch us. Without the horizon, our universe would be infinite to our senses, overwhelming, impossible to structure. Instead, we live inside a window, large enough to reveal grandeur, small enough to comprehend. The horizon is a reminder of both our greatness and our fragility. We are creatures capable of measuring the size of the observable universe, yet incapable of seeing beyond it. Some physicists speculate that the universe beyond our horizon may be wildly different. Perhaps the laws of physics shift, or the densities vary, or vast structures dwarf anything within our view. Perhaps there are regions where galaxies cluster more densely, or where voids stretch unimaginably empty. Some theories suggest an infinite universe repeating patterns endlessly. Others describe pockets of space with entirely different histories, different fates. We cannot know which is true, we can never know. The horizon draws its curtain and refuses to lift it, and yet, despite this cosmic censorship, the horizon teaches us something profound about boundaries. A boundary is not always a wall. It is not always something we can approach or touch or break. Sometimes a boundary is simply a limit to what can ever be known. The cosmic horizon is the universe's way of saying, this far and no further. It humbles us. It reminds us that our perspective is finite, that we do not see the universe. We see a shrinking island within it. But it also gives meaning to our cosmic story, because within this bubble, every star, every galaxy, every atom, every thought is connected through the same chain of observable history. We share the same cosmic past because we share the same cosmic horizon. Think of it this way. Everything within our visible universe originated from the same tiny region after the Big Bang. Every particle you have ever touched was once compressed into a space small enough to fit inside your palm, and so was every distant galaxy we can observe. The horizon is the boundary that marks the end of that shared origin. Beyond it, the universe may contain realms that did not grow from the same seed, did not evolve in the same way, did not belong to our cosmic family. They exist beyond history as we can know it. This realization invites both awe and dread. Awe because the universe is larger and stranger than we can ever perceive. Dread because we are fundamentally confined, not by walls, but by the laws of nature. Yet acceptance follows. The horizon teaches us to appreciate the beauty of the knowable, the poetry of the seen. It reminds us that limitations are not failures. They are the shape of our understanding. Without boundaries, consciousness would drown in infinite complexity. With boundaries, consciousness can bloom. And so, the cosmic horizon stands as the greatest boundary the universe has drawn. Not for itself, but for us. A reminder that we navigate reality through a keyhole, and yet what we see through that keyhole is already more than we can fathom. Beyond our horizon lies a universe we can never reach, and yet it shapes everything we see. Life began with a boundary so thin it could have been mistaken for nothing at all. A trembling film of molecules, fragile and permeable, wrapped itself around a pocket of chemistry on a young and restless planet. Inside that pocket, reactions unfolded with a strange persistence. Outside, the world roared on in shapeless indifference. This membrane, barely a few nanometers thick, became the first moment the universe drew a line from the inside. A line not imposed by gravity or force fields, but created by matter arranging itself in a way that declared quietly but decisively, "This is me. That is not." Everything before this moment had been boundaries drawn from without. Atoms were contained by electromagnetic shells. Stars were shaped by the balance of inward gravity and outward radiation. Galaxies were sculpted by dark matter halos and the web of cosmic evolution. Even the cosmic horizon was a boundary forced upon us by expansion and light. But now, for the first time in nearly 14 billion years, the universe produced a boundary that was self-made. A cell did not merely occupy space, it claimed it. It carved out an interior world defined by its own rules, rather than the infinite complexity of the world beyond. The membrane was more than a container. It was a declaration of identity. It controlled what entered and what left. It allowed nutrients to pass and toxins to be kept outside. It created a sanctuary in which chemistry could become biology. Without this boundary, molecules would drift meaninglessly, never settling long enough to form cycles, never guarding their reactions against the chaos of the environment. But with the membrane, life found a foothold, a protected pocket in which order could persist long enough to reproduce, adapt, and evolve. The simplest cell was astonishing not because of its complexity, but because of its insistence on separation. It created the first self in a universe that had known only undifferentiated being. Over millions of years, these boundaries multiplied. Cells merged, specialized, collaborated. Membranes thickened. Structures grew more elaborate. The line between inside and outside gained layers, detail, nuance. Some boundaries became defensive walls. Others became bridges, channels, receptors, pathways through which the self could trade information with the world. Life became a dialogue, conducted across borders. Every living thing evolved strategies to maintain its interior against the entropy pressing from all sides. The universe, once smooth and indifferent, now contained pockets of defiant stability, islands of self-sustaining complexity, linked by the fragile hope of survival. But the most dramatic shift came not with the invention of the cell, but with the emergence of nervous systems. Once organisms could sense the world, boundaries gained texture: sight, sound, touch, smell. Each was a negotiation between interior and exterior, between raw reality and the organism's interpretation of it. Sensory boundaries did not simply detect the world, they filtered it. They blurred some edges and sharpened others. They created a curated version of the universe that each creature carried inside itself. A private cosmos mapped onto a biological framework. As brains evolved, this mapping became richer, more abstract. A brain is itself a boundary, a fortress of interconnected cells that takes in signals from the outside and transforms them into internal meaning. It does not experience the world directly. It builds an internal model and lives within that simulation. In this way, consciousness is the universe folding back onto itself, observing itself through layers of interpretation. And with this observation came the most intricate boundary ever created: the mind. The mind is a borderland. It stands between perception and reality, between sensation and meaning. It filters, analyzes, constructs, imagines. It creates categories: self and other, past and future, intention and accident. These categories are boundaries, as real as any star's surface or any atom's electron shell. They shape how consciousness moves through the world. Without these cognitive boundaries, the mind would drown in raw data. With them, it navigates meaning. But consciousness did something even more astonishing. It created the boundary of awareness, the ability to recognize itself. When early humans first became aware that they were aware, a new line was drawn in the universe, a boundary that no star, no galaxy, no cell could cross. Consciousness became the first phenomenon capable of reflecting on boundaries rather than simply obeying them. We are not merely shaped by the universe's edges. We contemplate them. We imagine what lies beyond them. We question why they exist. This ability rewrote the meaning of the cosmos. For nearly all of cosmic history, boundaries existed without witness. Stars burned without knowing they were stars. Galaxies drifted without knowing they were galaxies. The cosmic horizon expanded without knowing it hid anything. But when consciousness emerged, the universe developed an interior gaze. It became capable of curiosity, confusion, awe. It became capable of asking why. And yet, this insight carried a cost. With self-recognition came the boundary between life and death, not merely as a biological fact, but as an existential boundary, a horizon of our own. Every conscious being learns that its interior world will one day dissolve, that the membrane of self will fail, that the boundary that defines identity is temporary. This realization is both devastating and transformative. It is the source of fear, but also the source of meaning. Without mortality, consciousness might never have felt urgency, never sought purpose, never asked the questions that define humanity. The boundary of death shapes the boundary of the self. As humans evolved, their boundaries grew more abstract. We invented moral boundaries, lines we draw around actions and intentions. We created social boundaries, cultures, languages, identities. We formed intellectual boundaries, disciplines, theories, categories of knowledge. Each of these is as real in its influence as the physical boundaries of atoms and stars. A concept can confine or liberate. A belief can separate or unite. A story can draw a boundary around a civilization. And yet, At the heart of this proliferation of boundaries lies a paradox. The more boundaries consciousness creates, the more it yearns to cross them. Curiosity is the desire to push beyond the known. Empathy is the attempt to merge interior worlds. Art is the expression that dissolves barriers between minds. Science is the quest to see past nature's limits. Spirituality is the longing to escape the cage of individuality. Love is the narrowing of distance between selves. Even the drive to explore space, to reach beyond our cosmic horizon, is an echo of life's earliest impulse to define itself, and then test those definitions against the vastness beyond. We are creatures of boundaries who strive to transcend them. This tension is woven into every aspect of human experience. Our cells defend their membranes fiercely, yet our minds imagine realities beyond all confinement. We build homes, nations, identities, only to feel restless within them. We seek safety, yet long for expansion. We crave belonging, yet hunger for freedom. We construct boundaries to understand the world, then question why those boundaries exist at all. This is the secret continuity between the universe and the self. Everything that exists is shaped by boundaries: atomic, gravitational, cosmological, biological, psychological. But only consciousness reflects on this structure. Only consciousness asks what lies beyond the edge. Only consciousness recognizes that boundaries are both necessary and incomplete. When we look at the night sky, we are not simply observing stars. We are witnessing the history of boundaries, the boundaries that atoms formed, that stars negotiated, that galaxies carved, that the cosmic horizon enforces. And as we gaze outward, something ancient stirs within us. The echo of the universe learning, piece by piece, to separate, to structure, to understand. Consciousness is the final link in this chain, the culmination of billions of years of boundary making. Through us, the universe contemplates its own architecture. Through us, the universe asks why it has edges at all. And so the journey turns inward. The boundaries that matter most are not the ones written in cosmic light, but the ones drawn within the mind, the place where the universe becomes aware of itself. Every thought is a boundary. Every emotion is a boundary. Every memory is a boundary. And every act of understanding is an attempt to cross them. We stand at the intersection of the infinite and the intimate. We are built from atoms that forged their boundaries in the early universe. We burn with energy born in stars that balanced collapse and radiance. We think with neurons that evolved to protect the interior world of the organism. And we dream beyond horizons that the universe cannot show us. At the end of this long cosmic story, after all the boundaries that shaped matter and space, we arrive at the boundary that thinks, wonders, fears, loves, and hopes. The boundary that looks at the universe and asks, quietly but profoundly, what lies beyond? We are the only boundary that tries to understand boundaries. In the beginning, the universe had no edges, no contours, no divisions. It was a boundless becoming, a swelling field of possibility without direction or form. Yet from that formlessness emerged a cosmos rich with borders, atoms with shells, stars with surfaces, galaxies with halos, minds with identities, horizons that no light can cross. It is tempting to see these boundaries as constraints, as limits drawn across an otherwise open infinity, but they are not cages. They are the universe's way of making itself possible. Without them, nothing could hold, nothing could differentiate, nothing could endure. Every boundary is a quiet act of definition. An atom's shell declares an inside and an outside. A star's balance between collapse and radiance gives it shape. A cell's membrane whispers self into the chaos. The cosmic horizon, vast and unreachable, outlines the portion of the universe that can ever enter our story. And consciousness, the most delicate boundary of all, reflects on every one of these edges, stitching them into meaning. Yet one mystery remains untouched: why the universe chose to build itself through boundaries at all. Why a reality that began without edges would carve them into every scale of existence. Why something, instead of dissolving back into nothing, insists on holding shape long enough for life to arise and question it. This final boundary, the reason for form, is the edge we cannot reach. It recedes no matter how far our understanding expands. And still there is peace in this unknowability, because every boundary we encounter, from the infinitesimal to the infinite, is part of a single cosmic gesture. The universe learning moment by moment to define itself. In the end, boundaries are not the universe's limits. They are the universe learning to define itself.